in order to graph rational functions, we need to practice finding key features of rational functions, and we're going to do that with these practice problems. Before I get started on practice problems, I try to remember to mark off all of the space I'm going to use for each problem. And then I always get out my notes. So I got out my notes from the last video. You can see I have my notes here and here from the last video that we made together. So if you need to pause the video to get out your notes from the last videos, you can do that now. For these functions, we want to get them into reduced form. And as we do that, we will identify key features about them. And the key features are the key features that we identified in the last set of videos with these sets of notes. It would be the domain and then the three different kinds of asymptotes and the holes that would constitute the discontinuities. So anytime you're looking at this, you'll want to factor the quadratic parts, whether they're in the numerator or the denominator. And in the first example, we see that our quadratic piece is in the denominator. So that's what we're going to factor. Y equals x minus 3 over, and then the quadratic function in the denominator factored is x minus 3 times x plus 5. And so the x minus 3 and x minus 3, they reduce to 1, and we get y equals 1 over x plus 5. And so with these couple of steps, we can see a lot of things. The first thing that we see is that the degree in the numerator is 1 and the degree in the denominator is 2. So I factored the quadratic function, and then I identified the degrees in the numerator and the denominator. And then I look for relationships. So then I looked for relationships here, and I saw that 1 was less than 2, which means we're going to look at asymptotes when it's less than 2. So let's look for when the degree is less in the numerator, because I remembered that I've got this relationship with the degree of the numerator less than the degree of the denominator, which means that I have an asymptote that's horizontal at y equals 0. So that's the first thing that we will write down. We've got a horizontal asymptote at y equals 0. So then when we're talking about asymptotes, we also want to look for the vertical asymptotes. And the vertical asymptotes, I remember, are the ones that are non-removable. So if it's non-removable, I can't get rid of the factor, and if I can't get rid of it, it didn't cross out. So I see here the x minus 5 didn't cross out. If I solved that for 0, it would be x equals negative 5, and that's where our vertical asymptote is. Then I remembered that vertical asymptotes are related to holes, because that's what we talked about. So I see that the holes cross out when the vertical asymptotes don't. So there's a hole at x equals 3, but a hole isn't just, so the hole, it's not just an x value, it's a y value too. So it's a point at x, y, and it's x equals 3, and it's whatever y is when x equals 3. So if I substitute x back in there, I get 1 over 8, so that's where the hole is. And then we would look for the slant asymptote here, and there's not going to be one because it doesn't meet that requirement to have a slant asymptote. So slant asymptote is none. And I've got all of these key features, and I'm going to write them down in a nice chart. So key features, we have asymptotes there's a horizontal one at y equals 0 and a vertical asymptote at x equals -5 with a hole at 3 and 1/8 with no slant asymptote. So then let's look at, so then the last thing I looked at was for holes. So let's look at number 3, the one right down beneath. So if we look at number 3, if we look at our steps that we took, we had to factor the quadratic part first. And if I factor the quadratic part of this equation, we get x times x plus 2, or x plus 0 times x plus 2 over x, and the x's cross out, and we're left with x plus 2. Now, even though we're left with a linear piece that y equals, we still have to consider the rational function that we started out with. So if you graph y equals x plus 2, it's going to give you a linear function, but x squared plus 2x over x is a rational function with different restrictions, with different key features, and that's what we're going to find. So the first thing I looked at was I identified the degree. I saw that 2 on top was the degree, 1 is the degree in the denominator, and 2 is greater than 1. And that told me from my notes from before, if we look down here, that if the degree in the numerator is greater than the degree in the denominator, then we don't have a horizontal asymptote. So let's just write that down here. Key features. And we've got no horizontal asymptote, none. So then let's look at the vertical asymptote, because that would be the one that would cross out. So the one that crosses out, no, that doesn't cross out. The one that doesn't cross out, because I can't get rid of it. So it's my factor that doesn't cross out, which is x plus 2, which means I would have an asymptote at x equals -2. So there's a vertical asymptote at x equals -2. And then I remember that if the horizontal asymptote, no, if the vertical asymptote, it's non-removable because I can't get rid of it. So the hole is a removable discontinuity because I can remove it. So because I removed that x, there's a hole when x equals 0. There's this hole when x equals 0. And if I substitute my 0 back into this equation in reduced form, I see that the y would equal +2. So there's a hole at 0 and +2. And technically, because when we divided, we got x plus 2 with no remainder. And because we didn't get a remainder, we still divided and that means that x plus 2 is the slant asymptote because it's approaching that line. So x plus 2 equals y is the slant asymptote. It's approaching this line. There's a special feature about slant oblique asymptotes and horizontal asymptotes that you can cross them, but you cannot cross a vertical asymptote. And then the last piece of key features we would find would be the domain. And the domain is when the denominator can't equal 0. So we would set the denominator x not equal to 0, and that's as far as we can go for the domain. So the domain is all of the values of x when it's not equal to 0. So these are the key features you will find by using your notes from the last couple of videos and the questions you've answered and working with your partner.